All right, so let's now talk about electrolytic cells. Okay, so last time we talked about galvanic or voltaic cells. Those are cells where you run a redox reaction in separate compartments so you can generate electricity, right? Now, in an electrolytic cell, what we have is the opposite. We have a redox reaction that is not spontaneous, but we want it to run. Okay, so if we want it to go, if we want to force it to go, we apply electricity instead. And so that setup is called an electrolytic cell. So you have a non-spontaneous reaction. So if you calculate the cell potential for that, it's going to be negative. If you want that actual reaction to occur, you have to force it. And so you apply an external voltage, okay? So you do electrical work. The external voltage that you have to supply must be larger than the absolute value of the cell potential. Remember, it's negative. It has to exceed that, okay? And uh, as far as terminology is concerned, where the oxidation takes place, you still refer to that as the anode. Okay, so it's always, regardless of whether it's a galvanic or electrolytic cell, oxidation is always said to take place at the anode, and reduction takes place at the cathode. Except that this time, the positive and negative terminals of your cell are switched in terms of the assignment of positives and negatives. So we say the anode this time is positive and the cathode is negative. Remember, in a galvanic cell, oxidation takes place at the anode and the anode is negative, right? That's where the electrons come out of. Well, let's try to understand why the plus and minus is switched here. Let's say you wanted copper ions to deposit at a piece of copper metal, okay? And let's say that process for the particular reaction you're interested in, that doesn't happen, so you want to force it by passing electricity through it. So let's say copper picks up 2 electrons to give you copper. Is that oxidation or reduction? Reduction, right? Now, where would that take place? At the cathode. So if you have a cathode, if you have copper ions, and you want it to pick up electrons, okay, what voltage must you have on this electrode right here? You have to make this negatively charged. You hook this up to the negative terminal of your battery. So you have a battery right here. The negative terminal of the battery is hooked up to that. Okay, so we say that the negative terminal of your electrolytic cell, okay, and this is not, circuit's not complete here, but you say if you want your copper to be reduced, then it has to be at the negative terminal. Okay, so the negative terminal of your electrolytic cell is where the cathode is. It's where the reduction takes place. Okay,